Hi and Assalamualaikum everyone. My name is Nurul and Fatihah Binti Ahmad Nazri, an electrical engineering student of UTHM.
And this is my supervisor.
Assalamualaikum, greetings. I am Dr. Ahmad Fateh bin Mohamad, the supervisor in this project.
So my project title is the prediction of photovoltaic power output based on real data using artificial neural network. This project was introduced when the demand of installing solar panel in many homes and business has increased. To ensure that the PV system produces the maximum power output, several aspects must be considered, including solar radiation and the temperature of the PV cell. This project proposed an improvement of PV power output prediction using ANN. The real data is collected from the PV panel that has been installed at UTHM. The computational method is constructed using power output formula, while the ANN configuration is constructed using the MATLAB software. The result of both methods will be compared, and ANN configuration produce more accurate outcome to the real data. The problem statement of this project is the PV power output can be predicted by focusing on the environmental factors such as solar radiation and temperature. There are two ways of predicting the PV power output for this project, which are the computational method and ANN configuration. The objective of this project is to collect the real power output data from the standalone PV panel at UTHM. The second objective is to predict PV system power output using computational method. And lastly, to develop ANN configuration to predict PV power output. This project methodology starts with the research on the PV system and ANN configuration. After that, I proceed with the collection of the PV data. The third step of this project is to predict the PV power output using the computational method. And the fourth step is to develop ANN configuration using MATLAB. After getting result from both methods, the result will be compared and will be proceed to the sixth step, which is analyze both of the result. If the result cannot be compared, then this project will go back to develop the ANN configuration. For data collection, this project store data in Google Form. The data is collected every day at 3 different times, which is at 9 AM, 12 PM, and lastly at 5 PM. The data collected are the weather condition, either sunny, raining, or cloudy. Other data collected are the PV output voltage, PV output current, PV cell temperature, lastly the solar irradiance. The ANN is developed using MATLAB. In the MATLAB, real data is imported from Excel to MATLAB workspace. The imported data are the PV output voltage, PV output current, and PV output power. Once all the parameters have been set, the program is executed. The accuracy of ANN can be derived from the regression graph. The overall regression demonstrates a strong similarity between ANN output data and the real data. The ANN output can be saved in Excel and compared to the result obtained from the computational method. The result for this project can be seen on the graph. On the left shows the graph of difference between ANN, computational method, and real data at 3 different times in one day. The right graph shows the error of comparison between computational method and ANN method. From the error graph, it shows that the ANN can predict more accurate result to the real data compared to the computational method. Thus, this concludes the project objective, where the ANN indeed can predict more accurate PV power output. The impact of solar system is it is effective way to minimize carbon emission, and solar energy produces no greenhouse emission, giving it both safe and environmentally friendly. Lastly, the A&N development can be helpful to the researchers, engineering, and students that study in the PV power system. This project can be commercialized to Solar Research Center, student in IPTA or IPTS, and lastly, Solar Training Center. These are the awards that I received in International Creative Innovation Idea Competition, and I also have received award in Innovas 2022. That is all from me. Thank you for watching.